Learning goals. Welcome to this learning session on calculating averages, mean, median, mode. In this course, we shall address Introduction to averages, understanding mean, median, mode, applying averages, choosing the right average, practice problems. There will be a quiz at the end to test your knowledge.
Introduction to averages. Averages are fundamental statistical tools used to summarize and understand datasets. They provide a single value that represents the typical or central value of a group of numbers, helping us make sense of complex information. The three most common types of averages are the mean, median, and mode. Each offers a different perspective on the central tendency of data, and choosing the right one depends on the nature of the data and the insights you wish to gain. For instance, understanding the average income of a country might require the median to avoid distortion from extremely high earners. These measures are widely applied in various fields, from economics and science to everyday decision-making. For example, a teacher might use the mean to calculate class performance, while a clothing company might use the mode to determine the most popular shoe size. Understanding the mean. The mean, often referred to as the average, is calculated by summing all the values in a dataset and then dividing by the total number of values. This method ensures that every data point contributes equally to the final average. For example, if you have test scores of 85, 90, and 70, the sum is 245. Dividing by 3, the number of scores, gives a mean of approximately 81.67. It is crucial not to round your answer prematurely, especially in scientific or financial calculations, to maintain precision. The mean is a widely used measure, but it can be significantly affected by extreme values, also known as outliers. A single very high or very low score can skew the mean, making it less representative of the typical value in some datasets. For instance, the average wealth in a country can be heavily influenced by a few billionaires, making the mean appear higher than what most citizens experience. Understanding the median. The median is the middle value in a dataset when the values are arranged in order from smallest to largest. This measure is particularly useful because it is not affected by extreme outliers, providing a more robust representation of the typical value in skewed distributions. To find the median, first arrange all data points in ascending order. If there is an odd number of values, the median is simply the middle value. For example, in the set 2, 5, 8, 11, 16, the median is 8. If there is an even number of values, the median is the average of the two middle values. For instance, in the set 1, 3, 6, 10, the two middle values are 3 and 6. Their average, 3 plus 6 was 2 equals 4.5, is the median. The median is often used for income data, as it provides a better sense of the middle class income than the mean, which can be inflated by a few very wealthy individuals. Understanding the mode. The mode is the value that appears most frequently in a dataset. Unlike the mean and median, the mode can be used for both numerical and categorical data, making it versatile for various types of analysis. To find the mode, simply count the occurrences of each value. If one value has the highest frequency, that is the mode. For example, in the set 1, 2, 2, 3, 4, the mode is 2. The mode is particularly useful in market research to identify the most popular product or feature. A dataset can have more than one mode, bimodal or multimodal, if two or more values share the highest frequency. For instance, in 1, 2, 2, 3, 3, 4, both 2 and 3 are modes. If all values appear with the same frequency, or if no value repeats, then there is no mode for that dataset. This is common in uniformly distributed data. This section provides a practical example of how the mean can be used to solve problems. We'll explore a scenario involving numbered cards and deduce missing information. Let's consider a practical problem involving the mean. Imagine Kayla has 8 numbered cards, 1, 2, 3, 4, 5, 6, 7, 8. She removes 2 cards, and the mean value of the remaining 6 cards is 4. We need to determine which 2 cards she could have removed. First, calculate the sum of the original 8 cards. 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7 with 8 equals 36. Next, use the formula sum of values equals mean number of values to find the sum of the remaining 6 cards. With a mean of 4, the sum is 4 times 6 equals 24. Subtracting the sum of the remaining cards from the original total, 36 minus 24 equals 12, gives us the sum of the 2 removed cards. We then look for 2 cards from the original set that add up to 12. Possible pairs include 5 and 7, or 4 and 8. This problem demonstrates how the mean can be used to work backward and deduce missing information in a dataset. Choosing the right average. Each average, mean, median, and mode, has distinct characteristics that make it suitable for different types of data and analytical goals. Understanding these differences is crucial for accurate data interpretation. The mean uses all the data points in its calculation, making it a comprehensive measure. However, it is highly affected by extreme values, which can distort its representativeness. For example, if a few very large salaries are included, the mean salary might not accurately reflect the typical income for most employees. The median is not affected by extreme values, making it a robust measure for skewed data distributions, such as income or property values. Its value may not always exist as an actual data point in the set, especially with an even number of values. The mode is suitable for categorical data and identifying the most popular item, but it may not always be near the middle of the data, and sometimes there is no mode at all.
Practice problem. Joe's marks. Let's apply what we've learned to another problem. Joe scored the following marks out of 20 in 6 maths tests: 11, 9, 5, 13, 15, 12. We need to determine how many marks he must score in his next test so that his new mean mark and his new median mark are the same as each other.
First, calculate the current sum of Joe's scores. 11 plus 9 plus 5 plus 13 plus 15 plus 12 equals 65. With 6 tests, the current mean is 65, 6 to 10.83. Arranging the scores in order, 5, 9, 11, 12, 13, 15. The current median is 11 plus 12, 2, equals 11.5. Let X be the score Joe gets in his next test. There will be 7 tests in total. The new sum will be 65 plus X. The new mean will be 65 plus X, 7. For the median, we need to consider the ordered list of 7 scores. The median will be the 4th value in the ordered list. By setting the new mean equal to the new median and testing values, we can find the required score. If Joe scores 14, the new set is 5, 9, 11, 12, 13, 14, 15. The median is 12. The mean is 65 plus 14 and 7 equals 79, 7, 11.29. If Joe scores 16, the new set is 5, 9, 11, 12, 13, 15, 16. The median is 12. The mean is 65 plus 16, 7 equals 81, 7, 11.57. If Joe scores 12, the new set is 5, 9, 11, 12, 12, 13, 15. The median is 12. The mean is 65 plus 12, 7 equals 77, 7 equals 11. Therefore, Joe must score 12 marks. This problem highlights the importance of understanding both mean and median calculations and how they change with new data. It also reinforces the idea that the median is less affected by extreme values, which can be a useful property when analyzing student performance or other data where consistency is key.
Summary. Well done, you have completed the course. Calculating averages. Mean, median, mode. you should now be familiar with Introduction to Averages, understanding mean, median, mode, applying averages, choosing the right average, practice problems.
Should you need to revisit any of the topics in this course, please use the menu
At the bottom of the screen.